Hello everyone, I've promised you a Ferris wheel question, so I'm about to go through the Niagara Skywheel question that was on one of the versions of the tests. The Niagara Skywheel has a diameter of 50 meters and completes one full rotation every 10 minutes. The bottom of the Ferris wheel is 2 meters above the ground. We're going to assume that the rider starts at the lowest point, and I think we need to start with the sketch first. The Ferris wheel is 2 meters above the ground, and so we assume that the rider is going to start there. So I will begin there with my sketch. So 2 meters above the ground. The diameter of the skywheel is 50 meters, so the maximum would be 50 meters above the 2 meters. So our maximum would be at 52. The center line would be halfway between the minimum and the maximum. So we're going to find our center line halfway between 2 and 52. The diameter is 50, so the halfway point would be 25 down from 52 or 25 up from 2. So we would do 2 plus 25 gives me 27 for my midline. I've added labels to my axes. Time and height is what we're looking at. We've talked about the height being between 2 and 52. The rider will get on at 2, and the tallest part is 52 meters above the ground. At this point, I'm going to consider the time. It says that there's a 1 full rotation every 10 minutes. So I'm going to label the scale on the bottom. All right, so I have the scale on the bottom with 10 and 20 minutes because there's a full rotation every 10 minutes. We already assumed that the rider was going to start at the minimum point or at the lowest point, so 2 on the y-axis or the height axis. It'll do a full rotation every 10 minutes, so it will be at 2 again after 10 minutes and then again after 20 minutes. The maximum, or the travel to the maximum, is going to be halfway between 0 and 10. So I believe it's going to be at 5. So we're going to put the rider at the maximum at 5 minutes. I'll do the same between 10 and 20. The maximum will be at 15. And then now I have my sketch. Excuse my messy drawing. Let's go ahead and start answering some of the questions. What is the amplitude? The amplitude is going to be the distance from the axes to the top or the distance from the axes to the bottom of the curve. So that would be 25. And that's our A value. What is the equation of the axis? The equation of the axis is the center line. So y equals 27. What is the period? The period is the length for a complete cycle. So our period is 10 minutes. So A is 25. This y value gives me a C of 27. And this period gives me a K. We're going to do 360 divided by 10. A K value of 36. Moving over to the medium, what is the equation of height over time, assuming the rider starts at the lowest point? Because the rider starts at the lowest point, I'm going to use the cos function. Normally for cos begins at the highest point. Because it's now at the lowest point, I'm going to use y equals negative cos x as my starting point. So since I'm using y equals negative cos, my amplitude is 25. I'm going to put the 25 in front of the cos. My k value is 36x. And then I'm going to add the equation of the axis at the end, so plus 27. My final equation then would be y equals negative 25 cos 36x plus 27. The next question, what is the height of a rider above the ground after 3 minutes? So that's when the value of x is 3. So I'm going to substitute x equals 3 into my equation. Putting an x value of 3 into the equation, and then using my calculator, I end up with 34.73 meters. So after 3 minutes, the rider will be 34.73 meters above the ground. The next question asks, how long does it take for a rider to reach a height of 30 meters for the first time? In other words, when y equals 30. I'm going to plug in y equals 30 and solve the equation. So by substituting in 30 for y, I rearrange, and now I have cos 36x equals negative 0.12. Now I just need to do the cos inverse, and then I end up with 96.89 equals, 36x. Last step is to divide by 36. So revisiting that, I ended up with cos 36x equals negative 0.12. Then I do the cos inverse. I get 36x equals 96.89. And then divide both sides by 36, I end up 2.69 minutes. So the rider reaches a height of 30 meters after 2.69 minutes. Moving over to the hot, the question says, if the diameter of the skywheel is increased to 60 meters while keeping the rotation period and the height of the bottom of the wheel above the ground the same, what would the new maximum height be? So knowing that they start 2 meters above the ground, we add 60 meters to get a maximum of 62. Our new A value will be half of the diameter of the skywheel, so 30. Our new equation of the axis, so that will be our C value, will be 30 down from 62 or 30 up from 2. So that would put me at 32. So our midline would be 32. Our K value is the same as it was before at 36. And now I'm just going to use the same equation, negative cos, because I'm starting at a minimum. So y equals negative 30 cos kx, so 36x, plus our C value, 32. To compare the speeds in this last question of the two Ferris wheels, I first needed to use the circumference formula to figure out how far is the distance for one revolution in each Ferris wheel. Our first Ferris wheel has a radius of 25 and our second one has a radius of 30. I'm going to sub in the formula. Using my calculator and substituting into the formula, I end up with the circumference for the first wheel to be 157.1 meters and the circumference for the second Ferris wheel to be 188.5 meters. Now we're just going to divide, because speed is distance divided by time. I'm going to divide by the time for one revolution, and in each case the time for one revolution is 10 minutes. Substituting into distance over time, I end up with 157.1 meters over 10 minutes, which gives me 15.71 meters per minute, and the second speed is 18.85 meters per minute. I hope that this video helps as you study for any makeup tests you might be doing tomorrow.